Assalamualaikum to Dr. Asmala. My name is Muhammad Iqbal Nur Hakimi bin Abdul Khalid, and my metric number is B0323105536, and I'm going to be presenting about our MATLAB project, which is automatic counting of rice grains using image processing in MATLAB. So, our firstly, our problem background. Manual counting of rice grains is time-consuming and prone to human error, especially in agricultural research and food industry applications. Automating this process using image processing improves accuracy and efficiency. So our project aims to pre-process an image of rice grains to enhance visibility, segment individual rice grains, and automatically count the number of grains using MATLAB. So next is our methodology. So our workflow includes several image processing steps, such as first step, we load and display original image. So first thing first, we load RGB image. For our situation, we call it rice.png, and we convert it to grayscale if it is an RGB image. If it is a black and white, so black and white image, so it doesn't require us to convert to grayscale. So step 2, we background estimation. So we estimate and remove uneven background. Lighting using morphological opening with a disc-shaped structuring element of radius 15. So next, we background subtraction. So we subtract the estimated background from the grayscale image to isolate the foreground, which is in our case, is the rice grain. So next, we do the contrast enhancement to improve image contrast using histogram stretching. In our code is called adjust. And next, we have image binarization. So we convert the enhanced image to binary format using imbinarize. So step 6, we noise removal. So we remove small noise particles, which is less than 50 pixels, using reopen. So lastly, we do the grain counting. Use connected component analysis to identify and count the number of rice grain. So I'm going to pass the next part for my friend Muiz.
Assalamualaikum, Doctor. I am Muhammad Ismail Samsudin. We are matrix number B0323104050. I'm going to do the demonstration for rice grain counting. First, we use image read. For the file name is rice.png. And then we have name, rice grain analysis, and position. Next one, we will convert the grayscale if we use RGB and create gray variable. But if we use gray image, then we just use the original image. Then step 1, with the original image histogram. This is made by me, with subplot 2 for 1. We will show first in original image from width and bold. Next one, we will show grayscale histogram font size. Width font size 10. Then intensity and pixel count. This is all for histogram. Then step 2, we will show the background model with bold from width. And then the third one, we will show the background remove, and follow up by correct the histogram. The next is the step 4. We will enhance the contrast for the rice grain. Last one, we show the binary image. Not the last one. The second last one, we will show binary image. We put front width. And then for the final result, we will show original image and also the detected rice grain. How many rice grain was detected? And last but not least, for the command window, we will show the total grains detected, mean intensity, and also image contrast. So now I'm going to run the MATLAB. It will take times. So you can see we have total grains detected for this image is 95, and this one. This will show how clear it is as a grain of rice. This was original image. This was detected rice grain. And this was original. Then we show the background model, and then we remove the background. Next, we enhance the contrast from the image, and then we will show the binary image. Okay, as you can see, total grains detected was 95, and mean intensity was 111.2, and image contrast was 164. Thank you, Dr.
Assalamualaikum and hi. My name is Muhammad Ijaz Ahmad and I will present the output and the conclusion. This figure shows 6 stages of how the RISE image was processed. The first is the original image, then the raw RISE image will be produced, and then the third step is the background will be estimated. The fourth step is a smooth version of the image to represent the background. It will be done using morphological operations. The fifth is the background will be removed. Sixth is the background is subtracted, so only the RISE grain remains clearly visible. The contrast will be enhanced. The image brightness and contrast are improved to make the RISE grain stand out. The image will be binarized. The image is turned into black and white. The RISE grains appear white. The background will be black. For the output though, the left side shows the original grayscale RISE image. The right side shows each RISE grain labeled in a different color using MATLAB's label to RGB function. At the bottom of the screen or in the command window, MATLAB also prints the total number of RISE grains detected. So from the sample output, we can see the MATLAB says that RISE grain is being counted, and then it will produce the analyzed result. For example, in this one, it shows total grains detected 134, mean intensity is 69.3, and the image contrast is 255. For the conclusion, this project successfully implemented a RISE grain counting system using MATLAB. The workflow from grayscale conversion to noise removal and labeling effectively isolates individual grain. The advantages are fast and repeatable results, scalable to larger images and datasets, non-destructive analysis. The limitations are accuracy may decrease if grains overlap heavily, highly dependent on image quality and lighting. And for the future improvement, we have planned to involve machine learning based segmentation integration into a real-time counting application.